In this lesson, we're going to be reviewing real number classification. So, kind of like a shortcut or a cheat sheet way of thinking about it is anything that is a real number that you've already heard of can be estimated or drawn or plotted on the real number line. And then you take those numbers and you think of them as two different categories. The first type would be rational numbers, and the second type would be irrational numbers. And these things cannot be overlapping. You're either rational, predictable, or irrational, unpredictable. And so rational numbers are numbers that can be written as ratios. They include some subsets too. Like, let's start with the smallest one here. Let's start with natural numbers. Natural numbers are another way of thinking about the counting numbers. Like how you learned to count when you were little. You started with 1, 2, 3, and then you kept going. When you add the number 0 to that set, you now have the whole numbers. Look, there's even like a 0 in the word whole. And when you add the opposites of those numbers, you have the integer set. So -3, -2, -1, and the 0, and the 1, and the 2, and the 3. Again, I want you to notice that there are no fractions or decimals yet. So when you get to this big category of rational numbers, we have fractions and decimals. But the decimals have to have some very specific criteria. So the rational numbers have decimals that stop, so something like 2.75, or repeat with a pattern that's predictable, like 1.5454, and then we might just write that on top. An easy way to see some rational numbers are to take the numbers and put 1 underneath and see if that would make sense. Like 5 is rational because you could write it as a ratio of 5 to 1. 5 divided by 1. And then some other rational numbers would be like perfect squares, the square root of 4, 9, 36, 121, etc. So that almost sounds like all the numbers that you know. Let's think about what irrational could be. The first one that always seems to come to mind is pi. Pi never stops and never repeats with a pattern. You can also make fractions out of irrational numbers, and they're still irrational. Or remember we said that perfect squares in a square root are rational? Well, non-perfect squares would be irrational, like the square root of 17. Punch it up real fast and see what we got. Never stops. We're assuming some rounding at the end of our screen. Never produces a pattern. Non-perfect square. I hope these shortcuts help you in the class. Good luck with the section.